In this video, we're going to look at the solutions to the Day 11 homework for Section 9.2, which is using our double angle identities and some given information to evaluate an expression. So if you look at example 1 here, we're asked for the value of sine of 2 phi, cosine of 2 phi, and tangent of 2 phi. I know that looks a lot like theta, but that's actually the Greek letter phi. So general process here is we're going to take a look at the given information. You're either going to be given interval for your angle, which in this case is 0 to 90, or you'll be given some information that'll help us identify in which of the 4 quadrants we'll be looking so that we can correctly identify our 3 trig functions, sine, cosine, tangent. Once we have those 3 trig functions, we'll be able to then use our double angle identities to evaluate sine, cosine, and tangent of 2 phi. So if we look at my given information here, like I said, we're looking between 0 and 90 degrees, which tells me I'm in quadrant 1, and then we're given that cosine of phi is 3/5. And what that information is really going to help you with, 3/5, is going to help you identify some sides of your triangle. So what I would do here is, again, we're in quadrant 1, so I'm going to draw a triangle in quadrant 1, and phi would be the reference angle in this case, and again, cosine of that angle would be 3/5, and because cosine is adjacent over hypotenuse, I can identify 2 of my 3 sides. And then to find the third side, you could use the Pythagorean theorem here, or if you know that a 3, 4, 5 triangle is a perfect Pythagorean triple, I can say that my third side of the triangle is 4. Now that I have all 3 sides of the triangle identified, I want to now find sine, cosine, and tangent of phi, because I'm going to use those when I evaluate with my double angles. So sine of phi would be 4/5, opposite over hypotenuse. Cosine of phi was given, which would be 3/5 in this triangle, and then tangent would be 4/3. So now that I have those 3 values for sine, cosine, tangent, I'm going to work through each of my double angle identities. So sine of 2 phi would be 2 sine of phi cosine of phi. And the way I think about this problem is, I'm obviously asked for sine of 2 phi. So when I see 2 sine of phi cosine of phi, I really think of those as really empty sets of parentheses. So what I like to write would be equals 2 times 2 sets of empty parentheses, and what's going to go in those sets of parentheses would be the values I just found from my triangle. So sine of phi is 4/5 and cosine of phi is 3/5, and that's really what I'm putting in place in my double angle formula. And now that I have 2 times 4/5 times 3/5, in order to find sine of 2 phi, since I have all values, I would really just need to multiply that out and simplify if necessary. So I would do 4/5 times 3/5 first, which is 12/25. So sine of 2 phi would be 2 times 12/25, or 24/25. So that's my first expression that I was asked to evaluate. For cosine of 2 phi, there are 3 different trig identities I could use. For the double angle of cosine, any of the 3 you can use. Just depends on what information from the triangle you have or want to use. The one that I typically use would be cosine of 2 phi would be 2 cosine squared of phi minus 1. That's one of the 3 different possibilities we have. There's really no specific reason why that one would be more valuable than others, other than for me, I see that I'm squaring cosine, and I wouldn't necessarily have to worry about a minus out front of my quantity like you would in the other 2 trig identities. But again, I'm going to use this one. So again, I like to think of cosine of phi as an open set of parentheses. So in my head, and I'm going to write it here, what I think of this as 2 times something squared minus 1. And that something is going to be cosine of phi, which we found or were given to be 3/5. So that means 2 cosine of phi would be 2 times 9/25, which is 3/5 squared, minus, and instead of 1, at this step I usually rewrite 1 in whatever denominator I have. So because cosine is 3/5 and I squared it, I got 9/25. I rewrite 1 as 25/25, just so that I'll have two terms with common denominators that I can subtract. So 2 times 9 over 25 is 18 over 25. If I subtract 1, or subtract 25 over 25 from that, I would get cosine of 2 phi to be negative 7 over 25. The last expression we're asked to identify or asked to evaluate would be tangent of 2 phi. So I'm going to write the double angle of tangent here, which is 2 tangent of phi over 1 minus tangent squared. And again, think of tangent of phi in the top and the bottom as really something I'm going to put a value in place of. So think of this as 2 times something over 1 minus that something squared. And what's going to go in those open set of parentheses? My advice would be to use parentheses, especially in the bottom, so that you make sure you don't, square the wrong value or consider that negative as part of your tangent value here. So tangent of phi in this problem is 4/3, so I'll put 4/3 in the top and bottom. And then I'm just going to simplify. So the top would be 2 times 4/3, which is 8/3. And then the denominator would be 1 minus, and then 4/3 squared is 16 over 9. So what I'm going to do here is simplify the bottom first. So I'm going to rewrite that 1 as 9 over 9 in the bottom. That way I can subtract the denominators. So if I subtract what's in the bottom, I would get tangent of 2 phi equals 8/3 over negative 7/9. And then I have a fraction within a fraction, so what I can do is rewrite this as tangent of 2 phi is 8/3 times negative 9 over 7, which is the reciprocal of the denominator. And then if I multiply across the top and across the bottom of those fractions, I would get negative 72 over 21, which reduces to negative 24 over 7. So that's kind of the process of using the double angle identities along with some specific given information to evaluate sine of 2 phi, cosine of 2 phi, and tangent of 2 phi. For number 2, we are given that u is between 3 pi over 2 and 2 pi, which should tell you that you're going to be looking in quadrant 4. And then we're told that tangent of u is negative 4. So what I'm going to do is draw a reference triangle in quadrant 4, and then use tangent of u is negative 4 to identify some sides. So negative 4 I think of as negative 4 over 1. So draw my triangle in quadrant 4. U is the reference angle. And then tangent I think of as opposite over adjacent, which means my sides would be, side opposite of u would be 4, side adjacent would be 1. And the 4 has to be negative because in quadrant 4 cosine is positive, or my x value of at any point I'm headed to the right, but then the other side of my triangle is below the x-axis, which means that side should be negative. And then there is no triple, a Pythagorean triple that's a 1, 4, anything. So to find my third side, I would actually use the Pythagorean theorem. So the hypotenuse squared would be 1 squared plus negative 4 squared. So the hypotenuse squared would be 17, so my third side of the triangle would be the square root of 17. Now that I have my third side, I want to identify sine, cosine, and tangent of u using my side lengths in my triangle. So sine of u is going to be negative 4 over root 17. And my advice would be to not rationalize at this point, since you're going to be operating with that side. Rationalizing it would actually make it more difficult to work with, because you'd get negative 4 root 17 over 17, and then that would probably be a little more difficult to work with. If you're going to rationalize, my advice would be to do it at the very end, and you'll see kind of how this radical in the denominator is going to work out in our problem. So in this triangle, cosine of u would be 1 over root 17, and then tangent of u is actually given to us, but again, if you check the ratio of your sides, you should get negative 4. Now that I have all three trig functions identified, I'm going to use those to evaluate the double angles for those. So I'm going to find sine of 2u. First thing I'm going to do is rewrite the double angle identity. You'll notice that that's going to be my first step every time, and the variable I use will be the variable that was given to me. So now we're dealing with the variable u instead of phi, like in example 1. So I'm just going to rewrite the identity using u, and then everything I work with notation-wise should be consistent, and I should use the correct variable. I know we'll have a tendency to use x or theta, but really only do so when that's the variable that's given, just for notation and accuracy's sake. So the right side is going to be 2 times something times something. Again, that's how I think about it. I'm going to replace sine of u with what sine of u is equal to in my triangle, and the same for cosine. So I'm going to replace sine of u with negative 4 over root 17 and replace cosine of u with 1 over root 17. Now leaving those unrationalized is, like I said, works out nicely in this case, because I'm going to multiply those two fractions together, multiply across the top and across the bottom. I would get 2 times negative 4 over, and root 17 times root 17 is 17. And then multiplying negative 4 over 17 times 2, I would get sine of 2u is equal to negative 8 over 17. To find the double angle for cosine, I would first choose which double angle identity I want to use. I'm going to use 2 cosine squared of u minus 1, and then replace cosine of u with what cosine of u is in this triangle. So I would multiply 2 times the quantity 1 over root 17 squared minus 1. Make sure you follow the order of operations here. I should square that fraction, then double it. So I usually do that in 2 steps, just for accuracy's sake. So I would call this 2 times, and then if I square 1 over root 17, I get 1 over 17 minus 1. 2 times 1 over 17 is 2 over 17 minus, and then instead of 1, I'm going to rewrite that as 17 over 17, just so I can now subtract those fractions. So when I subtract them, I get cosine of 2u to be negative 15 over 17. And then for tangent of 2u, first thing I'm going to do is rewrite the identity using u. So 2 tangent of u over 1 minus tangent squared of u. And then I'm going to replace tangent of u in the top and bottom with what was given to me. Tangent is negative 4. So then simplify the top and bottom. I would get tangent of 2u is negative 8 over 1 minus, and then negative 4 squared is 16. So in the bottom, subtract 1 and 16, I get negative 15. So tangent of 2u would be negative 8 over negative 15, or positive 8 over 15. For number 3, we are going to continue looking at our double angles. The difference here for number 3 is if you look at the given information, we're told instead of an interval for theta, like between pi and 3 pi over 2 or 0 and 90 degrees, we're given tangent of theta equals 4/3 and cosine of theta is less than 0. So what I like to do is think of that as, okay, where is tangent positive and cosine negative? And the only quadrant that I could be where that is true would have to be quadrant 3. So again, tangent is positive in quadrant 3, but cosine is negative. So the reference triangle I draw is going to be in quadrant 3, and that is really, really important to make sure you're in the right place, because if you're not, then your side lengths could be off in terms of whether they're positive or negative, which would then throw off how you evaluate your double angle. So just be careful here, make sure you draw an accurate picture, or at least know which quadrant you're working in. So I'm going to be in quadrant 3, so I'm going to draw a triangle. Now I'm working with theta, that's going to be my variable, and tangent is opposite over adjacent, so I know my sides are going to be 4 and 3, but they both should actually be negative. So my adjacent side would be negative 3, my opposite side would be negative 4, and I know those both have to be negative just because if I'm in quadrant 3, I have to go left first, then down, so both sides are negative. And then my hypotenuse, this is a 3, 4, 5 triangle, so my hypotenuse should be 5, and the hypotenuse of the triangle is actually never negative. So that's something to remember, especially when you're given, a ratio of sides, so you'll be able to identify which side should be positive and negative. So here's my picture. From my picture, I'm going to identify sine, cosine, and tangent. So sine of theta would be negative 4 over 5. Cosine of theta would be negative 3 over 5, and tangent of theta was given to us, which is 4/3. So I have my 3 trig functions, so I'm going to then find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So sine of 2 theta will be 2 sine of theta, cosine of theta. So I would replace sine of theta with negative 4/5 and cosine of theta with negative 3/5. So I'll multiply my two fractions together first. negative 4/5 times negative 3/5 would be positive 12 over 25. So I have 2 times 12 over 25, which is 24 over 25. So sine of 2 theta is 24 over 25. For cosine of 2 theta, you'll hear me say it a lot of times, you can use any of the 3 double angle identities, but I'm going to use 2 cosine squared of theta minus 1. I think that one's fairly convenient to work with most times. So cosine of 2 theta would be 2 times, and then what the quantity squared would be is whatever cosine was, which is negative 3/5, minus 1. So first thing I would do is square that fraction. So cosine of 2 theta would be 2 times 9 over 25 minus, and then instead of 1, you could do it obviously in multiple steps, but instead of writing minus 1 again, I know that since I squared 3/5, I got 9 over 25. So the denominator I'll be working with is 25. So I rewrote 1 as 25 over 25. So 2 times 9 over 25 is 18 over 25. And then if I subtract my two fractions, I would get cosine of 2 theta to be negative 7 over 25. Then for tangent of 2 theta, I would use the identity 2 tangent of theta over 1 minus tangent squared of theta. And then I would just replace the tangent of theta in the top and bottom with 4/3. So tangent of 2 theta is going to be 2 times 4/3 over 1 minus 4/3 quantity squared. And then simplify the top and bottom. So 2 times 4/3 in the top should give me 8/3 over 1 minus, and then 4/3 squared is 16 over 9. So I'm going to rewrite the 1 in the bottom as 9 over 9. So I'd get 9 over 9 minus 16 over 9 in the bottom. So if I subtract in the denominator, I'd get tangent of 2 theta to be 8/3 over negative 7 over 9. And then since I have a fraction within a fraction, I can multiply the top by the reciprocal of the bottom. So tangent of 2 theta would be 8/3 times negative 9 over 7, which would give me negative 72 over 21, which can reduce to negative 24 over 7. And then for the last problem in the homework, again, the given information is a little bit different than in problems 1 and 2. I'm given that secant of theta is 2. So the first thing I like to do is when I'm given secant is to go to cosine. So secant of theta is 2 means cosine of theta is 1/2. And that's because secant and cosine are reciprocals. So 2 and 1/2 are also reciprocals. So what I'm really asked for is to figure out which quadrant I'm going to be looking in where cosine is positive 1/2. And then it says cosecant is less than 0. So I think if cosecant is less than 0, that really means sine would also be less than 0. So the quadrant I'm really after is wherever cosine is positive and sine is negative. That would have to put me in quadrant 4. So the triangle that I draw here will be in quadrant 4, and the ratio of side lengths I find here would obviously be a consequence of that. So draw a triangle in quadrant 4. So I know that my adjacent side to my angle is 1, and my hypotenuse is 2, because cosine is adjacent over hypotenuse. And then you might remember the third side here, because this is one of our special triangles that we definitely worked with in previous chapters. And if you remember that, then you should say that the third side is negative root 3, because it's below the x-axis. But if you didn't remember that, I could use the Pythagorean theorem here. So 1 squared plus the third side, whatever the other leg is, squared, called a b, is 2 squared. So then solving for b, I should get root 3, and then I need to make that negative again because it's below the x-axis. That's just me verifying that that third side is negative root 3. But remembering that that's a special right triangle would be obviously a little more straightforward way to get there. Now that I have my triangle, I'm going to identify sine, cosine, and tangent. So sine of theta is going to be negative root 3 over 2. It would be the opposite over the hypotenuse. Cosine of theta would be 1/2. And again, theta would be the angle that's the reference angle in this triangle. Didn't draw it in there. Let me draw it in there for you. And then tangent of theta would be negative root 3 over 1 or negative root 3. So I have my three trig functions that I'm going to use to evaluate my double angles. So the first thing I'm going to do sine first. So sine of 2 theta would be 2 sine of theta cosine of theta. So then I'm going to replace sine of theta with negative root 3 over 2 and replace cosine of theta with 1/2. And then again, you can multiply, these are three things multiplied together. You can multiply them in any order, but I see that I have a 2 out front times a 1/2. So the 2 times 1/2 will actually be 1. So I end up with 1 times negative root 3 over 2 or just negative root 3 over 2. So sine of 2 theta would be negative root 3 over 2 in this problem here. Then for cosine, I'm going to use 2 cosine squared of theta minus 1. So cosine of 2 theta would be 2 times, and then in place of the cosine of theta, I'm going to put a half squared minus 1. So 1/2 squared is 1/4, so this becomes 2 times 1/4. And then instead of minus 1, I'm going to say minus 4 over 4, just because I'm going to end up subtracting those two terms anyway. So 2 times a fourth is 2/4, minus 4/4 would give me cosine of 2 theta equal to negative 2/4 or negative 1/2. And then lastly, looking for tangent of 2 theta, first write the double angle identity, and writing that at the first step every time is 1, good practice to make sure you are putting things in the right place, but 2, just helpful to keep these fresh in your mind. If you're writing them constantly and then evaluating them, there's a good chance you're going to obviously be able to recall them when you need to. You will have access to your formula sheet for the quiz and for the test, but as a resource, obviously we don't want to be super dependent on that. And if we're using them a lot and being mindful of kind of what they look like and where things go, it won't be that big of a stretch to feel comfortable using them. But you will have your formula sheet just in case. So then I'm going to put negative root 3 in the top and bottom where tangent of theta was. So I get 2 times negative root 3 in the top over 1 minus negative root 3 quantity squared. And this is one of the examples where I think it's really important to have parentheses around the negative root 3, because I would need to square that negative value first before that minus out front affects it. And if you don't have parentheses there, there's a chance you could, possibly call that a plus, which means you would have a slightly different value in the denominator, which would definitely affect your answer. So 2 times negative root 3 in the top is negative 2 root 3. And then negative root 3 squared is 3. So I end up with just 1 minus 3 in the bottom. Definitely not 1 plus, but again, if without the parentheses there, you might accidentally call that a plus 3, which would definitely affect your value. 1 minus 3 in the denominator is negative 2. So I have negative 2 root 3 over negative 2. The negative 2's reduce, which means tangent of 2 theta in this triangle and in this picture would be positive root 3. And those would be the three double angle values identified by using specific given information. Definitely drawing a reference triangle is a good step, and then finding sine, cosine, and tangent in your triangle right before you get started with anything, just to be sure that you have the correct ratio, you're dealing with the correct sides, and then you just follow through with the double angle identities and evaluate. That's the homework for day 11, and we will continue to talk about double angle identities in the day 12 notes.